Is El Nino here? Let's find out. I'm Mark Sponsler, and welcome to the Stormsurf Video Surf Forecast for the week starting Sunday, August 13th.
Stormsurf, waves, weather, buoys, altimetry, snow, temperatures, El Nino, weather analysis, essential data for outdoor people, all the time, no hype.
Be sure and like and subscribe. Ring the bell. You get automatic notifications when the videos are posted, typically on Sunday evenings. To subscribe, just hit the Stormsurf icon down there in the lower right-hand corner. And if you'd like to make a small donation, you can. Hit the heart, the special thanks button, the heart with the $sign in it down below, and you can make a small contribution. With that, I'd like to thank the folks that donated last week. We have Party Cat Pat, AJ Turpinning, E. Slate, Elliot Harris, Kim in California, MJO Surf, great handle, I love it. Jason Odom, of course, Sable Fisher, Spiffy Bobcat, and special thanks to Matt Rapp, who donated very generously. All right, now it's time to get to work. First off, let's take a look at current conditions. We're going to start in Northern California, looking at the buoys. Point Ray is buoy number 029. We're looking at all the energy that's hitting that buoy from way up at 33.3 second period. That's really energetic swell. And there's actually a tenth of a foot of energy hitting there. So nothing to be too concerned about. But there's a little bump here at around 20 seconds or so, and a larger bump at 15 seconds. Those are southern hemi swells that are both hitting right now. And then a little bit of wind swell at 9 seconds mixed in. Put that all together, we see primary swell, well, it's the wind swell, 3.7 feet at 8.6 seconds from 327 degrees. That would make surf at about waist high. But of more interest, secondary swell, 2.3 feet at 13.6 seconds. I think that's a little overcalling on the size and undercalling it on the period, and surf at waist high. Next up, we go down to Santa Cruz. Point Santa Cruz buoy number 254. Same deal. You see the clear bump of energy at 20 seconds and a similar, if not maybe slightly larger bump at 14 to 15 seconds is all southern hemi swell and no wind swell. All right, primary swell, 1.7 feet at 14.8 seconds from 200 degrees. Okay, that's surf at thigh to waist high. It's actually bigger than that. Secondary swell, 1.4 feet at 18.4 seconds from 188 degrees. That is, again, about the same size. The reality was, given the swell direction, and this isn't sorting it out, it was really more like 220 degrees. And there were waves that were head high to a foot overhead on occasion, and actually fun, rideable surf. Hooray! Finally, we have some waves. The second day of waves, too. There's probably more coming. Going down to Southern California next, Point Loma South Buoy. That's off of San Diego, but a good representation of most of the unprotected spots in Southern California. All the energy, again, the same profile, that 18, 19 second bump and the larger bump at about 14, 15 seconds. Primary swell, 2.2 feet at 15 seconds from 210 degrees. Surf at 3.3 feet, but you can double that at top bathymetric enhancing swell spots. You know the ones. That would put surf, instead of being like 3 feet, 6 feet or bigger. All right, and then secondary swell, 1.5 feet at 18.5 seconds from 196 degrees, 2.8 feet, maybe not double it, but there definitely is swell. And then finally, South Shore of Oahu, Barber's Point buoy number 238. We see it's the same southern hemi swell coming from under New Zealand, a little bit of energy scattered between 18 and 13 seconds. Putting that all together, 2 feet at 13.3 seconds from 190 degrees. That's surf at 2.5 feet, or that's probably chest high in the real world. And secondary swell, 1.1 feet at 16.5 seconds from 190 degrees, and 1.9 feet, but in the real world, that's probably waist high. So rideable surf at just about everywhere with south-facing breaks. This is a great relief. All right, so we're going to go take a look at the wave models. We're going to investigate what created this swell. All right, we're going back to Wednesday, the 2nd of August, so 11 days ago or so. A gale pushed over, and this is significant wave heights, the highest 1/3 of all seas in the ocean. We're looking, there's New Zealand there, Australia there, Ross Ice Shelf and Antarctica down here, and Chile, Peru, Central America up off the chart. You can see the gale, and this is just a tiny little thing. It's actually amazing how big the surf is given the just complete minimalness of the gale. 29-foot seas right here off of the tip, northern tip of New Zealand, lifting north with a secondary fetch into Thursday produced 24, 25, maybe 26-foot seas aimed north. That is the swell that's been hitting for the past 2 days, and bits of it will continue for the next day or so and then fade out. Now, the good news is that another gale did form, and we'll see if we can get this guy queued up right there on Wednesday night into Thursday, so just a couple of days ago, and let's see if we can get that right about there. So, yes, there's 20, 22, 24, 20, 22, 24, 26-foot seas there, and 20, 22, 24, 25-foot seas there, aimed pretty well off to the north, not for a long time, just 24 hours, but swell from that is radiating north. Now it's going to, for the most part, miss Hawaii, maybe a little dribble there. You can see there's some energy coming from that direction. Hawaii, Oahu at 158 west, so up off the chart up here. So maybe a little bit, and a little bit for Southern California, Central California, up into Northern California. So swell, another pulse for late next week, early the weekend sort of thing. Nothing probably as good as what we saw, just given that the seas aren't as high and the fetch wasn't as consolidated. But there is some swell on the way. Hooray, the dam has broken, we're out of the drought. So let's look out a little bit further in the southern hemisphere. All right, we're looking at Jetstream. The Jetstream up about 30,000 feet helps support the formation of gales, and you got to have a gale to create surf. And when the gales, or when you have a trough in the Jetstream, that would be a push in the jet to the north. That helps create a clockwise flow aloft and down at the ocean surface. That's the hallmark of low pressure. And of course, low pressure, if it's strong enough, generates winds. Winds get traction on the ocean surface and generate seas. Seas, as they radiate away from the fetch area to the north, eventually groom themselves out. The short period elements fall away, and you end up with swell like what we've had for the past couple of days. And of course, when swell hits your beach, it creates surf. All right, so really what we're looking for is a trough here in the southern branch of the jet. The ice line is right here at 64 south. The southern branch of the jet already crashing into Antarctica. It's as if it is already wintertime in the northern hemisphere and summer has set up across the southern, winter in the northern hemisphere. It's like summer is already set up in the southern hemisphere. We see the northern branch of the jet here at about 30 north and pockets of energy in it, but just this massive split between the two with no troughs. This does nothing to support gale formation. That said, we have been lucky and we've had a couple. And now, let's see, we'll just put this into motion. There's really no big change forecast until right around here, Wednesday, the 16th of August. You'll watch this. You'll watch the jet right in here starting to dig out, push to the north, right there, and you'll get your low pressure forming right in there. The southern branch also trying to feed up into it, not really doing anything, and normally we don't even look at this branch of the jet to support gale formation, but we'll take anything from the southern hemisphere. So it looks like there's some hope on, we'll say, Thursday into Friday. Now, this is all Southern California, San Diego at 117 west, so right about there. So this is really a California and Central America, of course, Peru, and maybe a Chile-based kind of event, but Hawaii out of the mix. And then we go beyond. We see the jet actually crashing south. That's not a good thing. And then we're into Sunday, a week out, and really no clear support except for maybe Chile over here. It looks like a trough maybe trying to develop. But that's a week out. We don't believe the model's more than about 4 or 5 days, so we'll see. So let's go take a look down at the surface, because you have to have winds blowing on the ocean's surface to create seas and swell. Actually, the beginnings of the Wednesday-Thursday event are already starting here, somewhere in the central-ish Pacific, and I'll pull the barbs. There you go. You see, this is actually Monday with 40-knot winds aimed to the north, lifting north and continuing into Tuesday, and then continuing into Wednesday, then fading out on Thursday. So a little bit of hope there. Otherwise, yeah, here's another fetch, but it's all aimed due south. Pretty much what the Jetstream suggested. All this fetch aimed at Antarctica here. 35-knot winds. That's the minimum you need for even like 13-second period swell. We really want to see 40-knot winds, but we'll take what we can get. And that seems to be it for the rest of the week. Let's go look at the effect of those winds on the ocean surface. So we already see some little seas, and as we get into Monday, we see 20 to 21 foot seas building into Tuesday. What do we got there? A little pocket of 26 foot seas. I'll pull that away one more time. And pretty well off to the north. And then continuing into Tuesday night at 25.4 feet. These are the highest seas in this whole domain. In fact, let's go back and see if it picked it up. That 29 foot, no, that's over here, so that doesn't count. So on Tuesday morning, probably peak seas 26.4 feet. And that'll take about a week to push to the north. That system fades out. Now, there's another system forecast here way down in the deep South Pacific with 32 foot seas. And then moderating pretty quick. So maybe a short blast, a little real south-angled swell for California also from that. We'll see how that all plays out. And then things go quiet again. Yes, gales, they're all falling south. No fetch aimed off to the north, resulting in no swell. Now, that said, last week we talked about a gale possibly developing in the North Pacific, and believe it or not, it did develop. Here is Friday, the 11th August, so a couple of days ago. Gale built with, what do we got? Oh, about not 37 foot seas. Look right there. Those are associated with the tropical system, so we'll eyeball it. 20, 22, 24, 26, maybe 27 foot seas. And continuing into Saturday and up to 28 feet midday Saturday. And now notice this is lifting northeast fast. Swell mainly in those sort of things. It gets down to maybe San Francisco, but not a whole lot more. And there is some little swell forecast to come in. We're talking 3.5 feet at 13 seconds or something like that. So nothing too much, but at north-facing breaks, especially as you get up into Oregon or so, maybe more likely for the first small push of northern hemi swell for the season. Just for fun, because we're going to get into this, we talked about this last week, about the North Pacific jet stream and its relative strength given the early time in the year. Looking quite good here on Sunday with up to a little pocket of 140 knot winds. It's consolidated. It's not split. This is classically what you'd see during an El Nino year. The jet starts looking pretty good. Now notice, there's a big trough that starts digging out on Tuesday west of the date line. Then the jet kind of peters out and you go, oh no, it's over, what is going on? But then as we get into next weekend, the jet starts rebuilding. Let's see how far we can get it out here to here across the North Pacific. Notice this big kind of almost trough digging out here. In fact, let's go back and look and see how that evolves. So it's sort of a split jet, but it's kind of a trophy pattern. That is good in terms of being able to dig out any lingering La Nina high pressure in the Northeast Pacific. We've been dealing with that pattern for all year now, and just lately it's beginning to look like, hey, this is the way things should look during an El Nino-ish or even a normal year off the California coast. So I think the La Nina curse, and I really don't want to say it, but it looks like at a minimum it's moderating for the time being. Significant wave heights for the North Pacific Ocean for Sunday. There is a little tiny sort of a gale thing forecast up here over the dateline with 20-foot seas. That could possibly push a little bit of energy down towards Hawaii. We also have a tropical system, two tropical systems. We can't get too much into the details because the websites are not functioning real well, but Fernanda right here, or Fernando, I think it is, building as we get into Wednesday and Thursday. The good news, it's supposed to dissipate before approaching the Hawaiian Islands, but then the models have steadily been talking about this mega strong tropical system developing here, and still to this day, I mean, it's been like 4 or 5 days this thing's been on the charts, lifting north, up, getting around Baja in the Southern California swell window. Clockwise, let's see, counterclockwise circulation would be like this. So this quadrant over here needs to get pretty west of Baja to be not blocked or obstructed by some of the parts of central and northern Baja here relative to Southern California. And the model does some funky things here starting about there. So for right now, it looks like it's right on the hairy edge of whether this will be capable of producing surf for Southern California. And we're not even talking about Northern California. This is be from Point Conception southward. So keep your eyes on that. We'll get another view of that. Maybe we won't on this model. But we also here looking for the potential for wind swell. Hawaii here, Central California, Southern California, Northern California, San Francisco right in there. Gradient, high pressure and control for the time being, creating north winds along the Oregon coast, mainly 20-knot north winds. Light wind regime along the central and northern California coast. Hooray. So here's Fernando, I think it is, pushing. Maybe we can drag this up just a little bit more so you can see that in the picture. So we get into Monday, more of the same, a bit of wind swell for North California, but nothing too much. And most of the fetch just sort of pushing away from the California coast. Trades 15 knots for the Hawaiian Islands. Tuesday, light wind regime for California. Trades 15 knots. The Fernanda hurricane status moving off to the east-northeast. Wednesday, light winds continue for California. Trades for the Hawaiian Islands. Thursday, same pattern. Fernando fading out. As we get into Friday, more of the same. This is kind of good for California. This speaks to that trough or whatever is trying to build in the upper atmosphere here, keeping winds at bay. That prevents upwelling, and that's a good thing. Maybe we'll get some yet warmer water temperatures along the California coast. So we get into Saturday. No real change. You see the beginnings of the large tropical system forecast creeping into the picture. Light trades for the Hawaiian Islands, light wind regime for California. Saturday, Sunday, how far can we go? We're at 168, 174 hours. I mean, it looks like swell is definitely has the potential for Southern California looking at this. And light winds, look at that. I mean, this is kind of smelling a lot like what an El Nino pattern would look like if you recall big tropical systems and past El Ninos. Here we go. It's looking like it's doing it. And finally, the wind machine for a whole week now is to settle down relative to California and relative to the Hawaiian Islands. Trades not strong. And a quick look at the National Hurricane Center. Fernanda. Sustained winds 65 knots, that's 75 miles per hour. Moving off to the west-northwest at 8 knots, and slowly expecting to fade in a day or two as it pushes off to the east. No threat to anyone, and maybe a little bit of background swell for Southern California, but nothing too much to get excited about. Surf spot forecast, we're looking at Half Moon Bay, wave heights. I mean, this is all wind swell, 2 to 4 feet sort of thing. This is the surf height. These are wind speeds here. Notice the very light winds just coming up in the afternoon, about midday, 7 knots. This is great. Haven't seen anything like this in a long, long time. Swell heights. So this is all 2.5 feet at 8 seconds. That's your wind swell. And then here is the northern swell from that system previously up in the Gulf, 3 feet at 12 seconds sort of thing. So what's that? 4-foot surf? Yeah, that's about right. On Tuesday, it'd actually be in the morning. And then fading down from there. And then you can't see it, but there is southern hemi swell buried in here. Maybe some of the other spots as we get down, there's just too much wind swell and it gets buried. And this only shows a primary swell, not secondary and tertiary swells. Santa Cruz, the same sort of thing. Here's your north swell, 3 feet, and then fading out. It's not really showing the southern hemi swell at all, but you see 2.6 feet at 12 to 13 seconds fading out. And then bits of energy beyond that from the northwest, but 2 feet at 11 seconds, but at least a little bit of wind swell. So then we go down to Southern California, Dana Point. This is all protected from the wind swell. You see surf heights, 1.7, 1.6 feet. Then coming up at 2.8 feet as we get into Friday and Saturday of next week. Let's examine the details. Fading swell from the southern hemi, 14 seconds, 13 seconds, a couple of feet, or not even a couple, 1.5 feet, something like that. And then another little pulse of southern energy, 1-2 feet on Tuesday and Wednesday at 13 to 14 seconds. And then as we get into Friday and Saturday, yet more southern hemi energy. Nothing particularly big. What's that? 2 feet at 15 seconds sort of thing from the south. But rideable waves pretty much all week. South shore of Oahu, 2-foot waves pretty much, and then fading below that. Surf heights, 1 point, this is lingering, New Zealand swell, 1.7, 1.9 feet at 12 seconds, fading to 10 and 9 seconds. Maybe another little backup pulse of some generic swell, 2 feet at 11 or 12 seconds, and then fading out. All right, let's go take a look long term. There's 2 major weather oscillations that affect the potential for swell development, both in the southern hemisphere, though more loose in the southern hemisphere, but certainly much tighter coupled in the northern hemisphere in winter months. That is the MJO, the Madden-Julian Oscillation, and of course the El Nino Southern Oscillation, the MJO being a 6-week on, 6-week off oscillation. El Nino, once every 7-year type event. We'll start by looking for signs of the MJO, the active phase of the MJO. There's 2 phases to the MJO. It sort of turns on and then it turns off. The active phase and the inactive phase. The active phase is like a low pressure system. The MJO rotates around the planet from west to east on the equator. Active phase on one side of the planet, inactive phase on the other. They rotate around like that. It is when the active phase moves over the Pacific, starting over the West Pacific and then moving east, it does 2 things. One, by virtue of it being a low pressure system, it takes warm moist air from down at the ocean surface, lifting it aloft high in the atmosphere. That adds energy to the jet stream, and a stronger jet stream, of course, feeds the development of gales and therefore storms and surf production. Likewise, the active phase, as it's moving across the Pacific, because it's a low pressure system, it dampens trade winds. Trades are generally driven by high pressure. If high pressure is reduced, the speed of the trades decrease, sort of like what is forecast to happen in the Pacific over Hawaii and California over the coming week. All right. Now, the inactive phase does the exact opposite. It basically feeds high pressure, increases trades, steals energy from the jet stream, and suppresses storm development. So we're looking for the active phase of the MJO. One other thing the active phase of the MJO does is when it dampens trade winds as it's moving across the Pacific, that allows warm water that's normally pushed into the far west Pacific to start sloshing east, driven by Coriolis force. And it creates like a ball of warm water that travels from west to east on the equator, but actually under the equator, down 150 meters. It's known as a Kelvin wave. If you have successive active phases of the MJO, they create successive Kelvin waves. Those Kelvin waves eventually erupt off of Ecuador and the Galapagos Islands, creating a pool of warm water there. And if you get successive active phases, you get successive Kelvin waves, and you start getting a buildup of warm water off of Ecuador, and that's how you start El Nino. And that's exactly where we are right now. We've had 5 active phases of the MJO during the springtime and early and winter, last winter, that created 5 Kelvin waves that erupted off of Ecuador and are still erupting to this day. It takes like 4 months for a single Kelvin wave to push across the Pacific, so it's a slow-moving bulldozer, if you will. So this is what is helping to feed the development of El Nino right now, and it was an extremely robust series of active phases and Kelvin waves that resulted, which initially got us thinking we were moving into super El Nino status. The point of tonight's video is to try to get a sense of, well, where is all this going to play out? Are we still going to get super El Nino? And I'll just say right now, probably not. But is it going to fade, and how strong is it going to be, and all that? We're going to try to tease out all those details. All right, so we're looking for signs of the active phase of the MJO. Remember I said it's like a low-pressure system. It dampens trade winds. So this is data from the TAO buoy array, a series of buoys strung across the equator used for monitoring El Nino. They have wind sensors on the buoys. And imagine sticking buoys a whole way across the Pacific Ocean on the equator and having to maintain that mess. That's an expensive and manually intensive process. But anyway, the good news is those buoys, you can see the arrows here, give us 5-day average winds, mean wind speed. The longer the arrow, the stronger the wind. So pretty strong east trades in the east, pretty strong east trades over the central Pacific. But notice you get to about 175 east, boom, they stop. You actually get little bits of westerly winds. That smells like the active phase of the MJO. Now, the other thing it could smell like is a developing El Nino, because once El Nino really kind of gets settled in, you don't even need it acts like a long-running active phase of the MJO, just continuously producing westerly winds over the West Pacific, taking every drop of warm water here, pushing it off to the east. Now, it's not the actual means that matter, it's the anomalies, difference from normal for this time of year. So we see, looking at these arrows, yeah, trades are a little bit stronger than normal over the East Pacific, but dead calm over the Central Pacific. And out of the West anomalies the whole way to about 160 west. So this definitely looks like, at a minimum, the active phase of the MJO, or now one could maybe say this is the beginnings of a legit El Nino circulation developing on the surface. Maybe. Hard to say. We're going to have to dig a lot deeper. What have the winds been doing for the past 5 days? Okay, this is the same deal. 850 millibar vector wind anomalies. So this is sort of like satellite-based, model-based, not quite sure exactly. But it shows you the east-west component of the wind. Now, the 850 millibars is up at 4,700 feet, so it's not quite at the surface, but a pretty good proxy. South America there, Central America there, Hawaii there, Australia, New Guinea, the equator there, dateline there. We're only interested in the far West Pacific right here, because that's where this reversal of trade wind things is used to, one, impart energy to the jet stream, and mainly in the northern hemisphere in winter months, and two, to create Kelvin waves. West anomalies too far here, they don't do anything. So it's from 170 west, 5 degrees north of and south of the equator, to about 125 east. So right here, we call it the Kelvin wave generation area. So on the 7th of August, west anomalies were in play. 8th of August, west anomalies. 9th, yes. 10th, yes. 11th, maybe not as strong, but some degree of more westerly than easterly anomalies. That's exactly what we want to see. Again, suggesting at least the active phase of the MJO, if not a developing surface El Nino pattern. All right, so here is the forecast. 850 millibar zonal wind anomalies, just the east-west component of the wind. This is for the whole planet, right? But we don't care about the whole planet. We only care about that specialized area in the West Pacific, Kelvin wave generation area. It starts at 120 east, so right here. Dateline's right there, 180, and 170 west, so right about here. Now, this is what's been happening, and the reds are westerly anomalies. Look at this. Westerly anomalies have been blowing since July 15th in the Kelvin wave generation area, nonstop for almost a month. That is really a good sign. But here we go, Kelvin wave generation area, easterly anomalies. Looks like the inactive phase is supposed to set up for 5, 10, 11, 12 days. Okay, that's not too bad. And then westerly anomalies, again, come roaring in after that. Now, this is the GFS model. I'll call this the curmudgeon model. It's never a good thing with the GFS model, or it overhypes for a little bit and then it always falls apart. Well, this is showing easterly anomalies for the next 12 days. Let's go look at some other data. So here's another way of looking at it. Here's the equator right here. This is just your standard, it looks like a regular old wind model, right? Okay, 5 degrees north and south of the equator, Kelvin wave generation area, out to the date line. Let's see, date line's roughly around in here. So this is the box we're interested in. But also, it's good to see west anomalies in the East Pacific too, because we've had a lot of easterly anomalies that have sort of been like mixing up a lot of warm water that's there and kind of muting it. All right, so let's just put this in motion. This is 2 weeks worth of data. Here is our, there is our east wind thing the GFS was talking about. But then we get into, let's see where we go here. There we go. We're on to Saturday the 26th, and west anomalies return and build, and pretty strong, and taking over. So this window that the model is suggesting, let's go back here. We'll see where it starts at. It's pretty much starting today, according to the GFS, and holds in some fashion until, I'd say about the 24th or 25th of August. So that's only a week. That's, that's 12 days. Sure enough, same thing as what we saw before. And then taking over the Pacific. So, not so bad. And yet one more view here. Now this is, again, the whole planet on one chart. The reds are west anomalies. That's what we want to see. The blues are east anomalies. This is the GFS model. Now you can see the land masses here. There's India. There's the maritime continent there. Right there, that's where the West Pacific starts. So going right down there. Okay, date line right there. And the Kelvin wave generation area just to about there. So the GFS model says some lingering version of westerly anomalies actually holding in portions of the Kelvin wave generation area, but easterly anomalies pretty strong starting today, 18Z. Continuing, now this only goes out to the 22nd. I think I said it was the 24th or the 25th where the easterly anomalies start fading. So that's the GFS model. The GEFS model, the ensemble version, pretty much saying the same thing. Now, one more model, the ECMWF. This is the European model, the European version of the GFS model. It says, no. Westerly, maybe get some easterly anomalies for a couple days. Then for the most part, westerly anomalies in control. And by the 20th, for sure, they just take over and doing pretty solid and strong here in the eastern and central Pacific. Interesting. So, and the ECF model has consistently been saying we're not going to have some sort of a big east wind event, while the GFS is continuing to say that. So, who knows? I guess we're going to find out. Next up, outgoing long wave radiation. That's just fancy words for cloud cover. Are there more or less clouds over portions of the ocean? All right. If the active phase of the MJO is good for building El Nino, and the active phase of the MJO is a low pressure system, then low pressure systems typically produce clouds. Right now, this is the statistic model, and this just goes out in 5-day increments, out 15 days. South America, Central America, Hawaii, New Guinea there, Australia there, equator there, date line there. Kelvin wave generation area right here. Now the yellows and oranges here represent cloud-free skies, high pressure. That would be the inactive phase of the MJO, the bad phase of the MJO. And the statistic model says inactive phase building, just like what the GFS is saying, and peaking out about 2 weeks from now. Now here is the GEFS model saying, not so quick. The inactive phase trying to get going, but not really doing anything, and we just stay neutral. So that's maybe not as bad as what we thought before. And then the drill down for these two models. This is the statistic model here, dynamic model here. What are we looking at here? Well, it's a chart that shows where the active phase of the MJO is and how strong it is. So the MJO moves from west-east, from the Indian Ocean to the Maritime Continent, to the West Pacific, to the East Pacific, under the United States, across the Atlantic, over Africa, back to the Indian Ocean. The heavy dot right here is where the active phase is, so in the far East Pacific. And these are 3 different possible tracks. If the heavy dot here is inside or near the circle, the active phase is considered extremely weak. If it's out here, it's considered very strong on the outer peripheries of the chart. All right, so weak active phase forecast moving basically to the Indian Ocean over the next 2 weeks and staying weak, and modest at best. Now, the GEFS model says active phase of the MJO just noodling around in the East Pacific for the next 2 weeks and not doing anything. So neither of them. What we really want to see is this heavy dot up here somewhere up in the West Pacific and raging. But we don't see that right now. Upper level moisture chart. This is up at Jetstream level. The greens area is favorable for precipitation, roughly equivalent to the active phase of the MJO. The yellows and oranges, dry air, cloud-free skies, and the inactive phase of the MJO. South America here, Central America, New Guinea there, equator there, dateline roughly there. The main area we're looking is right here, Kelvin wave generation area with a little bit of precip in it. So active phase of the MJO really looks like it's more in the East Pacific, which is exactly what we saw in the other charts, and slowly fading out through about the end of August, with the inactive phase trying to push across the Pacific. But notice this little lingering bit of precipitation hanging. This might be, and this is a reach, but maybe another sign of the beginnings of El Nino starting to manifest itself in the atmosphere. We've been talking about for weeks now, and when we get into the subsurface ocean stuff, you'll if you're new to this, you'll see a clear El Nino signal. But El Nino has to not be just in the ocean; it's also got to be in the atmosphere. If you go to a lot of the major news sites and all that sort of stuff, El Nino's coming. They're all screaming with their hair on fire, and they're showing you ocean temperatures. And that is a good precursor for El Nino, but it is not literally El Nino. It is the oceanic component of El Nino. If the atmosphere isn't responding to what the ocean's doing, you get la nada, which is nothing, or a false start El Nino. So we've been harping now on pins and needles. Is it happening? Is the atmosphere going to respond? And it's kind of been this back and forth thing the whole month of July, when in reality, looking back at some of the data now, we've seen there's been a lot of westerly anomalies blowing, and there's some sort of sense that the atmosphere is going on. And if you get in the comments section, me and some of the other guys have been debating in depth about the micro details of when the Walker circulation is going to set up and that sort of thing, which is a major component. That is the final, that is the ground truth of El Nino, when there is a permanent trade wind shift in the Pacific Ocean, and it's like a massive active phase of the MJO sets up over the dateline, like a chimney of air just going straight up in the atmosphere, and you have west anomalies on the surface continuously, like a long-running active phase of the MJO in the West Pacific, and east anomalies in the East Pacific, and they're all converging somewhere in the middle of the Pacific on the equator, and then all that moisture blasting high up into the atmosphere. And that's the classic El Nino sort of thing. So that's what we're looking for. Now I've gotten way off track here, but seeing this little bit of moisture just lingering the whole way through the model suggests maybe that's trying to happen. And this inactive phase, it tries to push across the Pacific, not looking very strong at all. And we have active phase here, and this moisture here as we get into the beginnings of September continuing. Looks, and remember, the seasons changing too play a huge part in helping to drive the development of El Nino and the coupling of the atmosphere to the ocean. We're waiting for that to all happen. We're seeing small signs of it, but we want to see a clear, bright light pointing at us saying, here we go. We think we're getting there, but let's dig a little deeper. So if the GFS model is the grumpy model, the CFS model is the happy model. And everyone loves a happy face, and I do too, and I get sucked in by it a lot. But then I get disappointed when it's not what the model projects, it's the ground truth of what's happening right now. It is, so this is that same sort of thing, the east-west component of the chart, of the atmosphere, east-west components of the winds, the reds and oranges, westerly anomalies associated with the active phase of the MJO. In fact, MJO, black solid line right here. There's an active phase of the MJO with strong westerly anomalies. Now, this was back in May. Oh, and Kelvin wave generation area. It has to happen within to 125 east to about 170 west, so right there. Dotted contours, inactive phases, there's been a couple of those. But then starting somewhere around July 15th, yeah, we have a active, just the smallest week. It's not even really an active phase of the MJO. And they say literally during El Nino, the active phase of the MJO disappears, but wind-wise and symptom-wise, everything is just like a massive 3-month running active phase of the MJO. Well, if I see westerly anomalies running for a full month, I go, okay, well, that's maybe the active phase of the MJO. I'll give it the benefit of the doubt and say, yeah, I'll be a curmudgeon and say, that's just the active phase of the MJO. And then we have these little bit of easterly anomalies. Even the CFS picks up on it, but that's a week there. And this says only for, okay, we'll give it 5 or 6 days. And then solid westerly anomalies building after that, the whole way into September. You don't get westerly anomalies from July through September on a single active phase of the MJO. So this is smelling, and remember, we're going through the seasonal change here too. So this is smelling more if it verifies. What I mean by verifies, if it really happens. Not someone selling us a bunch of hype that, oh yeah, it's going to come, it's going to come. I'm not going to do that to you. I'm saying if this actually happens, if we go 1, 2, 3 weeks from now, and we've got westerly anomalies pretty much over this whole stretch, we're in the money. We are that close to finally this long soap opera that you all been hanging on watching since January. We are within the next 2 or 3 weeks of pretty much being, off to the races. All right. Looking good per the CFS model. Now here's the CFS model, only goes out 3 months. And what's already happened is down here, and what's forecast to happen is up here. Now this is outgoing long wave radiation, cloud cover. The blues, cloudier in skies. If we were having the Walker circulation in the active phase, the MJO, all lined up on the dateline, you're going to have a lot of clouds on the dateline. Well, there's the dateline. Here's what has happened. The blues are less sunlight reflecting off the ocean surface. Negative anomalies, meaning more clouds. Okay, you can clearly see the forecast here into November, massive cloud cover over the dateline. But actually, if you sit here and look, you go, well, wait a minute. Since June 10th, it's not like a solid wall like that, but really there's not any yellow in there at all, meaning it's been getting steadily cloudier. And at the same time, this is verified data here. It's been getting steadily drier over the maritime continent, which is all the classic signs of the El Nino development. In the forecast, you can see it for yourself. Lots of clouds from here forward. Now, here's what we normally go look at. Let's pop out. We look at 850 millibar zonal winds, but they're saying the exact same thing, going back into not June, because it was June 10th, but even then you could see it was really July 12th, something like that. Steady westerly anomalies in the Kelvin wave generation area. And the forecast is steadily building and stronger and stronger and stronger into October. Classic El Nino setup with easterly anomalies feeding into it, with this suggesting the center of the Walker circulation maybe right on the date line. Let's see if I can pull that other one up. Yep, and that's saying the center of the cloud cover right on the date line too. Interesting. Okay, now let's overlay the MJO just for fun. All right, solid contour, active phase of the MJO. We've been in the active phase of the MJO. We got maybe 2 days left of it in the Kelvin wave generation area, and it's over. Now, here is the inactive phase of the MJO. Typically, you get easterly anomalies with it, but no, the model says westerly anomalies for the next 1, 2, 3, 4 weeks. We'll see, but if we get even a moderate westerly anomaly pattern, then we're in a clear El Nino signal. And you can see it's not just light little yellows, it's these dark cores in here suggesting, I mean, these would be a westerly wind burst, a strong westerly wind event. And then once the active phase of the MJO sets up in mid-September, we're off to the races and gone, and we're deep into El Nino. Now, the last little piece of the puzzle, the low-pass filter, the high-pressure, low-pressure bias, right? Okay, that would be the Walker circulation. Winds pushing in this direction from the west to the east, getting sucked up into the air. If you had rising air on the date line, that's low pressure bias. So 1, 2, 3 contours started back in July. Sure looks like El Nino, and it's only supposed to continue and get more solidified as we go into the fall. And notice the high pressure bias. This is the La Nina indicator. It's barely hanging on south of California. I think that's what's been responsible for those strong northwest winds and the upwelling and the cold water pattern that we've been harping about for weeks and weeks now. It's supposed to be completely gone as we get into. This has been, the end point has been varying between October 18th, pretty much October 18th for weeks now, and that's still what it's saying. So the model unwavering in its support for the development of El Nino. So let's dig into the El Nino situation now. We've been talking MJO and sort of atmospheric stuff. What's happening in the ocean? All right. West Pacific here, East Pacific here. This is data from the TAO buoy arrays. Buoys strung across the Pacific, 2 degrees north and south of the equator. The X's are these are the anchor lines on the buoys. The X's are sensors strung down the anchor lines. The sensors pick up data on subsurface water temperature. They're looking for Kelvin waves, the signs of Kelvin waves, and then use a model to fill in the obvious gaps in between. 30 degree centigrade anomalies, that's really warm water. They were back at 175 or even 177 last week. They're to 171 or 172 this week. The 29 degree isotherm, it was at 158 last week. It's moving off to these. This is suggesting that warm water is pushing off to the east. The 28 degree isotherm still locked at 145. I mean, at one point it was over at 120, and we've been in a pause for a while, and that's what kind of got us a bit perplexed. We want to see this starting to move east. The 24 degree isotherm holding at, what is that, 25 meters deep. Okay, it was down at 50 or almost 65 at one point, so suggesting not as much warm water in the east as there was weeks ago. Now, anomalies. This is the real picture. The subsurface temperature difference from normal for this time of year, and what grabs your eye? 5 degrees centigrade. That's what, 8 or 9 degrees above normal Fahrenheit in the far East Pacific. That's the result of multiple Kelvin waves, in the 5 Kelvin waves we were talking about earlier, impacting here, all overlaying on top of each other, bleeding off to the surface. But the good news is here, another bulge of 2 degree anomalies from that westerly wind pattern that we saw since July. That's been, we kind of blew it off and said it's just this insipid west wind pattern. It ain't going to do anything. It's not strong enough. But sure enough, even though it's maybe not as strong as some of the previous events, it was long-lasting. It set up momentum. It's take warm water over the maritime continent, bleeding it off into the Pacific Ocean, creating a ball here. When this ball starts moving east and lifting up, it's going to get warmer. This is 3+ months out from getting over here, so that's, where are we, August, mid-August to September, October, November. that was what we needed to really get our El Nino into its final thing. We needed another pulse of warm water getting to the east. It looks like that's going to happen now. And we don't see any real cold anomalies. We thought we saw a pocket pop up here. It's like, what is that? But it's gone now. So of no concern at the moment. Here's another version of that. This uses satellite data to estimate sea subsurface temperatures. You can see temperatures here. Let's do the contour count. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. 5+ degrees, 5 to 6 degrees here. So that's a little bit warmer than the other one. And we see this nice robust flow of 1, 2, 3 to almost 4, 1, 2, 3 to almost 4. So we'll call it 2-degree anomalies right here. So those two versions of what's happening in subsurface look consistent with each other. Sea level anomalies. This is the satellite data that is used to create the subsurface profile. What is this measuring? These are not temperatures. These are the height of the ocean. Polar orbiting satellite measures the height of the ocean as compared to the perfect sphere or the standard sphere of the ocean. You strip out the wind waves, strip out the waves, strip out the tides. And is the sphere higher or lower than normal? Why does that matter? Well, if you have cold water at depth, cold water contracts. It'll create a divot on the ocean surface. Warm water likewise expands. It'll create a bump on the ocean surface. So, Chile, Peru, Central America, Hawaii up there, equator there, dateline here, New Guinea there. What are these yellows? These are all positive values. Not high, 0 to 5 centimeter. There's your 5 centimeter. That means there's a bump there. That means there's warm water subsurface there. That is our next Kelvin wave there. And then all this 5 centimeter stuff out here, this is your classic El Nino warm pool. Multiple Kelvin waves backed up here and spreading north and south, creating your El Nino signature. Now again, these aren't temperatures, these are ocean heights, and then you infer the temperature of what's going on down in the ocean from this data. But everything we're looking at is consistent, and that's what helps build confidence towards a forecast moving forward. Upper ocean heat anomalies. I like this chart a lot because it shows you over time what's going on. West Pacific here, East Pacific here. The blues colder than normal temperatures. This goes back a year. So August of last year, massive cold pool off over, and it's just on the equator, 5 degrees north and south of the equator. So this is your classic La Nina pattern. While the trades are nuking, blowing from east to west, pulling up warm water here in the far west Pacific. Well, we got the active phase of the MJO in November last year, made a little baby Kelvin wave. That just started the process. Kelvin wave number 2 in January, Kelvin wave number 3 in February, March, Kelvin wave number 4 in April, Kelvin wave number 5 in May. Here's your massive warm pool. Now you see it's starting to discharge a little bit now, and we know that to be true. But here is developing Kelvin wave number 6 right here. All this looking good. Now during the other mega El Ninos of 97 and 82, and for that matter even 2015, this warm pool would be discharged by about June or July, and you'd start seeing cold water building up over here. Now this El Nino, we thought it was going to be a super El Nino. It's evolving a little bit slower. To me, that says it doesn't necessarily mean a bad thing, but it could mean a longer lasting El Nino. It's taking longer to evolve, but it's definitely evolving. And to have a Kelvin wave in August, I think that's kind of a good thing. What do you think? Here's the CFS model for subsurface temperatures, right? And this is kind of hard to read, but and this is for June. This is looking back. So 120 east, that's the far west Pacific there. Ecuador's at 80 west, so right there. So here is our existing warm pool in June, and there is your little trickle of warm water coming through the maritime continent into the West Pacific. That continued in July, and August still continuing. Now notice as we get into September, there's still a little bit of warm water here, but for the most part in the far west Pacific, the Kelvin wave machine dries up. But you still have a massive pre-existing batch of warm water here with another Kelvin wave feeding into it. You can see the extent of the deep reds here building as we get into November and even into December. And then that pool starts discharging, cool water starts building. Don't even want to think it, but that's the coming La Nina behind this. And then March and April, warm water still lingering into April. That's an interesting development. But we don't see any more Kelvin waves of any, well, I don't even want to say of any magnitude, but there is warm water lingering in the West Pacific. Is it enough to create another Kelvin wave? Probably not. But whatever El Nino this is, my sense is it's maybe slower to evolve, but that also means it might be slower to devolve as we get further into next year. That's a good thing. All right, sea surface temperatures. We've looked at what's going on in the atmosphere that's helping to create Kelvin waves to push them across the Pacific to impact Ecuador, and then they erupt to the surface. Here is the yellows and oranges, warmer than normal waters. South America, Chile, Peru, Ecuador, Central America, Hawaii. Where's Hawaii? Oh, there it is, right there. Now, the one bit of the fly in the ointment here is this cool pool that was all along California, and this is sea surface temperature anomalies, difference from normal for this time of year. So basically, the cool pool rapidly collapsing with this week's lack of winds along the California coast. And you also see a warming pattern off of California, especially up in like Cape Mendocino and north of there. Still little bits of pockets off of San Francisco, cooler than normal. And then warmer, well, you can see here's the main warm pool here, the Galapagos there, Ecuador. Now, not as warm as it was days and months ago, but still warm, dragging out across to about 138 west, something that being caught by the trades, building up into Baja and almost into Southern California, down to Patagonia. I mean, this is classic El Nino pattern temperature distribution. Trend the past 7 days, well, notice a little bit of cooling right here. We know that east trades are building stronger than normal there. We know west trades are stronger than normal there. We also see building warming here along Baja, along Central America, off of California, and for sure the whole way across the Pacific. One would look at how warm it is here off of Japan, or how much warmer than normal it is for this time of year, and any tropical system that gets up here has lots of fuel to supercharge itself and then move across. We're looking for recurving tropical systems. Tropical systems like typically come across like this, and then during El Nino, the years they start drifting up towards Japan, they get caught by the trades, and then come back at us into the Gulf of Alaska. The earliest I've seen any sort of a swell of any size, I mean, we're talking like chest-high surf, from a recurving tropical system per memory here is like August 15th. I don't think we're going to see any of that this year. But in the 97 El Nino, there was a mega 8 to 10 feet pure swell at 25 seconds, slamming into Northern California on September 28th, I think it was. So we're getting into that ballpark or into that time frame. We'll see if we get anything like that, but probably not, but we'll see. The good news here is the cool pool is shrinking. Sea surface temperature index in the Nino 1.2 area. This is the area right there by the Galapagos in Ecuador. Today's value plus 2.2 and 642 thousandths of a degree above normal. Fading slightly some. We were up to 3.2 at one point, so we're down by about for a day or two, or give it a week, let's say. So we're down 0.6 of a degree from that, and we expect this warm pool to slowly discharge and start getting blown off to the west into the Nino 3.4 region right here. Nino 3.4 is the area on the equator south of California out to about the dateline 5 degrees north and south of the equator. Temperatures there up to 1.048. So we've only been above 1 degree. So let's be clear. 0 is neutral. Even the start of the weakest of El Nino in the Nino 3.4 region is half a degree above normal. So that started in, what is that, beginning of June roughly. So that would be a weak El Nino. A moderate El Nino is 1 to 1.5. So we're just barely tickling the bottom of the moderate. We got to get up to 1.5 degrees to get into strong El Nino territory. So we're still a ways off from that. And you can see the trend upward has been woefully slow. So just for comparison's sake, let's look at sea surface temperatures compared to a bunch of other stronger El Ninos, 82, 91, the 97 Super El Nino, 2009, 2015, 2023. And this is sort of raw, unverified data. It's weekly data for the life of those El Ninos. You can see the 2015 El Nino here up at 397, 1997 in the 2.25 range, 82 got up to 2.6. 2009, not so strong, 1991. But here we are, 2023, not in the Super El Nino category at where we are right now at week 31. And I think this data is, I don't remember what week 31 is, but it's a couple of weeks ago. But not in the 91, 2009, and even beating out 82. Now, this is not corrected data. Let's be clear here. You know, the seas are getting steadily warmer, so warm temperatures now are not as warm as what less warm temperatures were in 82. But still, just gives you a rough idea. We're not in a bad place. Let's look at some corrected data. Here is RONI, the data that is every 5 years they update the baseline because they know the oceans are getting warmer. So this is probably a more true sense where we're at. And this is monthly data. It's not weekly. And this was as of June, something like that. Okay, and this is not just 5 El Ninos. This is pretty much like every El Nino that's happened since 57. 57 was a super. 82 was a Super El Nino, 97 was a Super El Nino, 2015 was a Super El Nino. Here we are plugging our way up the curve, and this is, puts us about in line with the 63 El Nino, which got to moderate status. Is that really true? Is all we're going to get is a moderate El Nino out of that? Or are we going to get more like up into here? I'm hoping, now here's 2009, which ultimately got to the bottom end of a strong El Nino, and we're doing better than that now. So it's hard to say exactly where we're going to end up. There is a lot of debate that could be had here, and I'm not going to do it now. So here's the profile for this year's El Nino. We're just going to go back real quick in time. Here is 2015. I think we're way stronger still than 2015, though 2015 by this point in time was starting to get warmer out here in the Nino 3.4 region. This year, we're so eastward displaced, it's insane. Now let's look at 97. 97, there's no comparison. Cooking warm as of August 12th of 97. We're not in that ballpark. Are we in the ballpark of 2015 or not? That is the question. I guess we're just going to have to wait and see. One other thing I wanted to show you, ocean surface currents. Now you see the current going hard east off of the Galapagos, taking warm water that's all palled up here, and we believe dragging it this way. Now here's the other really cool thing. You go to the West Pacific, and you see the current flowing hard west to east, okay, on the equator. The dividing line between the two, I'm trying to figure out, well, there's your easterly current, there's your westerly current, probably the spot somewhere right around here, and that is 167 west, One could argue, well, with that little bit of easterly right there, it's at 170, but somewhere 176 west, but somewhere around here, we'll say 170 west. We think that's where the center of the Walker circulation is, and that these two currents are being driven by winds, west anomalies there, east anomalies there, hitting this point and then lifting up into the atmosphere. That maybe is a reach, but we're looking at the available data, and that's what I think is happening. All right, one last piece of information. What does the atmosphere think is going on in terms of pressure? The Southern Oscillation Index, the difference in pressure between Darwin, Australia, which is kind of in the Indian Ocean, and Tahiti, which is clearly in the central Pacific near the equator. Okay, when pressure is lower for Tahiti, the index goes negative. Today it's 5.16. But negative, 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 negative. It's been negative for, I don't know, I didn't count them, 28 days, let's say, less the past 2 days. So that clearly suggests, at a minimum, the active phase of the MJO. We saw all that, and we saw westerly anomalies, and all this is supposed to collapse. So maybe this is the pending inactive phase of the MJO starting to show up. The 30-day average, now it's a 30-day look back, minus 13.24. You can see we went in a month from positive 2.42 the whole way down to minus 13.24. So clearly a disposition towards lower pressure in the Pacific Ocean. The 90-day average, now this is going way back. We're at minus 5.56. Today we're at minus 8. But this is looking back in time over, we're not there yet. This is going to continue to drop. In fact, let's look at this data graphed out. Here's the 30-day moving SOI graphed out. Downward spikes are the active phase of the MJO. Upward spikes are the inactive phase. That is rising pressure versus lower pressure. In January 1st, well, here's the zero line right here. So this is all positive pressure in the Pacific Ocean, La Nina. January 1st, boom, just collapsed. Went way down to minus 20. We kind of had a little bit of a back off in July or so. Now here we are heading down again. Hopefully we'll keep falling. We'll see. This is all about now. We know that we have the inactive phase coming for maybe 10 days, 12 days. So big question mark kind of where we're going. But if we were going into El Nino, we want to see this dropping maybe down to as low as 25. Forecast sea surface temperature anomalies for the Nino 3.4 region from the CFS model. This is the official El Nino monitoring region. So where are we here? We're in mid-August, so that would be right about here. Temperature's about 1.15 degrees. And according to this, from here on out, steady upward trend of temperatures reaching 2.15 to 2.2 degrees. And I don't know how long of a period of time that is, maybe a week or two, something like that. That's moving into super El Nino status and then slowly fading from there. But as of May of next year, still above normal, still in El Nino range. Looking at the PDF corrected version, the more corrected version, the more conservative version suggests temperatures building to, about 1.7. So this is weak El Nino from 0.5 to 1, moderate from 1 to 1.5, strong from 1.5 to 2, and anything above 2 is super. So this says strong El Nino. We've been having some discussion on the forum and saying, in reality, this probably, between the two of these at 2.2 and this at 1.7, the reality is we'll probably get to about halfway in between those, so maybe a 1.8 or a 1.9. What's your guess? How warm do you think it's going to get? I guess we'll see. No one knows right now. Good time to place your bets. All right, so quick point. Where are we at? El Nino status as of today. New developments. Weekly building cloud pattern. That's negative OLR. Continues near the date line since June 24th. Evidence of the upflowing of the Walker circulation there. Equatorial currents suggest the Walker circulation is already in effect at the surface. Okay. Then the North Pacific Jetstream is holding for now. We know it's going to back off a little bit, but it's supposed to come back. The SOI has backed off some. West wind anomalies have been holding over the Kelvin wave generation area since 7:15. Those are all very positive suggestions. Also, new Kelvin wave development continues. Great news. ENSO models all suggest more of the same moving forward, and if anything, are upgrading some. But the inactive phase, the MJO, I don't even know if I'd call it that. Yeah, it is. The models say inactive phase. It's coming, and West anomalies are to back off for some period of time. So, the unknowns. Is the Walker circulation building towards El Nino? We think it is. It's not manifest. It's not super obvious, certainly not in the upper atmosphere, but down the surface, I think some degree of it is happening. We're giving it a 75% yes, 25% no. Will west wind anomaly pattern continue over the Kelvin wave generation area? Perhaps with a 2-week stall, but 70% yes, 30% no. Are more Kelvin waves in flight or expected? Yeah, one more. Is the ocean and the atmosphere coupled? We think we're getting there. We're 65% certain, 35% not completely sure. I might even upgrade that a little bit with this week's update. Will the warm pool in the east discharge before coupling occurs? Say probably not. There's another Kelvin wave in flight. There's piles of warm water there. It will discharge some, but not completely and not certainly go cold. Is the model guidance believable? 65%, 35% yes. 65% yes. I'm thinking maybe even more, but let's give it a week. All right, let's come up out of the rabbit hole. Let's get a breath of air. The good news is, hey, there's surf 2 days in a row, and there's more coming. I mean, there'll probably be waves for the next couple of days, rideable small southern hemiswell, then a refresh later in the week into next weekend, and it looks like yet another gale beyond that is developing the next couple of days. That'll give us surf for the week beyond that. So finally, sort of the end of summer, we're getting a little breath of fresh air and something to ride. It's been a long, ugly, 7 weeks or more since when? The end of June? All of July was nothing. The first, 6 weeks of no surf of anything more than thigh high. So this is good news. Looking beyond, well, a little bit of North Pacific swell. Maybe we'll filter into a couple of top spots. Nothing real rideable, but something. And the jet stream, theoretically, looking okay. We'll see what happens in the next week or two. But the seasonal change is coming. The days are already starting to get shorter. Summer is coming to a close from a surf perspective, and the transition to fall is starting. We think that will push and help fuel El Nino. And once we get through this last little, 10 days, 12 days of easterly anomalies, theoretically, we're off to the races. Things are looking good. We are so close, you can almost touch it and hold it. We're not there yet. So, with that, that is the end of our forecast for this week. If you enjoyed the video, give us a thumbs up. We really appreciate it. If you have questions, write them up. We're having vigorous debates on all the minutiae of how this is going to play out. I want to hear your opinion. What are your thoughts? How warm do you think the Nino 3.4 area is going to get? Give us your best shot. Any guess is good. What the heck? We don't know anything. We're just making the best of it with what limited data we have. Like all of us, we're groping in the dark, trying to make the best of our situation and have a little fun in the process. If you'd like to donate a little money, that would be great. If not, that's cool too. We like just having you here, and we like having the conversation. And with that, be sure and like and subscribe. The little icon down there in the far right-hand corner. And with that, we are done for this week. I know we rambled on. Enjoy, go get some surf, have a good time. You've earned it. It's been a long, dry spell. And with that, we'll see you next week. Same time, same channel. Thanks for watching.